So in this video, we're going to solve a quadratic equation using the quadratic formula. So we're asked to solve x squared minus 2x plus 5 equals 0. We could try factoring this equation, but as it turns out, it's not going to factor very well. So let's remember our quadratic formula. It says x is equal to negative b plus or minus the square root of b squared minus 4 times ac all over 2a. We could show where this comes from through a process of completing the square, but for right now, as long as you can memorize the formula, you'll always have it ready to use. So it's important to list what our a, b, and c are. These are the coefficients of our equation. So the coefficient of x squared is a, that is 1. The coefficient of x is negative 2. And the coefficient, or the constant term for the last term, is 5. So now we can plug these in. Negative 2 is going to be positive 2, plus negative 2 squared minus 4 times 1 times 5, all divided by 2 times 1. Now this portion inside the square root is actually called the determinant because it determines the number of solutions that our equation will have. If the determinant is 0, we have only one solution. If the determinant is a positive number, we have 2 real solutions. And if the determinant is negative, we have 2 imaginary or complex solutions. So let's take it a step further and simplify. So we have 2 plus or minus. Negative 2 squared is 4. 4 times 1 times 5 is 20. So we have 4 minus 20, all divided by 2 times 1 is 2. So let's take a moment to simplify this further. 4 minus 20 is negative 16. And so I'm going to have net x equals 2 plus or minus the square root of negative 16 is 4i all over 2. And so we can simplify this further. 2 divided by 2 is 1, and 4 divided by 2 is 2, so plus or minus, this should be a 2 times I. Going one step further, we can write these as 2 distinct numbers. So we have 1 plus 2i and 1 minus 2i. So that should be an I, not an x. So these are our 2 solutions. And as we saw in our last video, these 2 complex numbers are conjugates. We have 1 plus 2i and 1 minus 2i. So it satisfies that conjugate pair theorem that we mentioned. This works for any quadratic function, whether the roots are complex or real. My first preference is to try to factor whenever possible, but if factoring doesn't work, you can always rely on this quadratic formula to help us solve any quadratic equation.